Hello and welcome to this section 5.3 lecture today for Algebra 1 Part 1. Today we're going to be looking at solving proportions with cross products. So we talked yesterday a little bit on how just to solve proportions, more like a solving equation strategy. And today we're going to go over one old method and one new method to solve a proportion. So the first one that we see here is the officially now the reciprocal property. If two ratios are equal, then their reciprocals are also equal. Yesterday I used the example of 1/2 and 3/6 being equal to each other, and then flipping those over, where now they don't equal the same thing that they did before. They're still equal to each other. So when you flip over 1/2, you get 2/1, which is 2, and when you flip over 3/6, you get 6/3. Which is also 2. So those are still equal to each other. The last method we're going to talk about is what's called the cross product property. In other words, it's basically a look at what most people would probably know as butterfly math. And by that I mean that when we take these two and multiply them, it's equal to these two when we multiply them. And it kind of looks like a butterfly, but I'm not very artistic, so I don't like to think of it that way. And I enjoy drawing shorter lines. So I think of multiply those two, set them equal to each other, and there you go. So we're going to look at some different strategies, some different times to use different strategies, because most of these strategies are going to work no matter what you're looking at least maybe a combination of the two, of two of the three, sorry. But sometimes there's a better way to do it, okay? So let's go ahead and get started. I want to look at the difference between the reciprocal property and the cross products property with this same problem. So reciprocal property, I need to use it since y is on the bottom, right? I'd say y/3 is equal to 8/5. And then I would use what I kind of coined as the solving equation strategy of just what's happening to the variable, undo that, and we get y is equal to 8 times 3 is 24, so 24/5. And remember, I do not multiply that 3 by the 5 because that 3 is really 3/1. And in multiplying fractions, we multiply top by top, bottom by bottom, and we're good to go. So that's one way to get there. The cross products property, or butterfly math if you will, says 5 times y is equal to 3 times 8. And then we have to solve this equation. What's happening to y? It's being multiplied by 5, so I will divide that and see if I have to reduce, which I don't, and I get the same answer. It's going to be up to you to decide which way is quicker and easier. Some people like this method because it gets rid of fractions, and I know a lot of people are very afraid of fractions. At the end of the day, our answer is a fraction, so it's only going to get you so far, but it does take fractions out of the scenario for the time being. Let's go ahead and take a look at some of these problems. And since I looked at reciprocal property yesterday, I'll probably focus a little more on cross products. So let's go ahead and do that on this first one. On this first one, I have 12 times 4, which is 48, is equal to 16 times x. What's happening to x, and how do I undo that? I need to divide by 16, and it turns out that 48 divided by 16 is equal to 3. The only other thing that would have made that a little bit easier would have been to reduce this, but even that would have made things a little bit weird, so I avoided it for the time being. Next one, I've got something else happening to x down here. So I could use reciprocal property and then undo everything happening to x, but that would be a little bit complicated. I think it's just as good to use your cross products. 7 times 2x is 14x, and 4 times 3 is 12. Divide both sides by 14, and we get x is 12/14, or probably better off to say 6/7. They're both multiples of 2, so we can divide them both and move on. This one, let's say I'm on a roll here, and I'm good at using my cross products. Let's go ahead and do that. C times 8 is 8C. 5 times 9 is 45. And then I divide by 8. And we get C equals 45 over 8. Now that's one way to do this, and that is totally valid. There's nothing wrong with doing this problem that way. But I bring this up because we talked about an easier way, I consider it to be easier. It's less work, it's less thinking to do this problem. Oops, that's goofy. It's less work and thinking to do this problem using just the solving equation strategy. And that C is on the top, so I can just multiply both sides by 9. 9 times 5 is 45. That goes over 8, and that equals C. I'd be done right then. I'm going to leave it to you to decide which way you'd like to do those types of problems, but I'm just trying to let you see that you don't always have to use butterfly math. Okay. Let's look at some of the problems on the back. So moving through these, this is another one. I don't need to use butterfly math. X is on the top and it's all alone. When X is on the top, when my variable's on the top and all alone, I can just use the solving equation strategy. Even if it's not all alone, even if there's something else happening here, I can use this, but I'm going to look at times that it might be a little bit easier to cross multiply. So X is equal to 2 times 3 is 6 over 5. And I'm done. It doesn't reduce. And yes, it is the same as 1 1/5, but you know me, I'm not a big fan of mixed numbers. I'd rather see improper fractions. They're a little bit cleaner. This next one, we might as well use cross products. 2 times 3 is 6. There's a C on that one. 5 times 3 is 15. I can divide by 6 on both sides, and I see that C is going to be equal to, well, they're both multiples of 3, so I can divide them both by 3, and we get 5 over 2. Okay. Now let's look at this next one. This is where we get some more advanced stuff happening. There's something else happening to y. Okay, and if I was doing the reciprocal property and then solving equation strategy, I could do that, but I'm going to go ahead and cross multiply this one. It's going to get a little bit ugly before it gets better looking, but this is where the real work on these problems comes into play. 9 times 5 is 45. On this one, I'm kind of stuck writing an intermediate step because I have 24 times this whole y plus 2. So I have to write it as this. And now I have to distribute. So we're going to take 45 equal to 24 times y plus 24 times 2. And now we have an equation to solve. It's a two-step equation. We'll subtract 48. And we get negative 3 over here is equal to 24y. Divide both sides by 24. And we got a little bit of reducing here. This is actually negative 1 over 8. So you can see where these problems can get to be a little bit more difficult as there's more things happening to your variable. Now, I will say that you could have still done the reciprocal property and solved this, and I think it would have been a little bit easier. I do want to show you what that looks like just to see. I'm not trying to convince you to do it one way or another, just trying to give you options. Okay, let me actually make that a little bit smaller so it can kind of shimmy in over there and be somewhat out of the way. We will notice that even if we choose to do this problem a different way, a lot of the same numbers that we got, we're still going to get. A lot of the things are still going to be, still going to happen. But I would claim that they happen a little bit easier. So the thing that I did here is I just flipped it over, reciprocal property. I'm going to multiply both sides by 9 because that's the first step to solving this equation, is to multiply by 9 because the addition in here is actually in a hidden set of parentheses up there, which we talked about before. 9 and 24 actually reduce. They're both multiples of 3. So I'm going to reduce those now just to make my life a little bit easier. Now I can see where this problem is going to be. Doing it this way is going to involve something that we like to avoid. 3 times 5 is 15, and 1 times 8 is 8. Here's what we like to avoid and why we don't typically use this strategy. Because now I have to subtract 2 on both sides. Okay, and subtracting 2 from this fraction is I need common denominators. I'm going to call it minus 16 over 8, which is 2 with a denominator of 8. 15 eighths minus 16 eighths is going to be negative 1/8. Okay, so that's probably the part of this problem that's a little bit harder to do that we got to avoid by using cross products. Okay. So I would advise probably use cross products. I made it look easy, but that's because I knew what was coming. I'd get a lot of wrong answers that said 13 over 8. I want to avoid those wrong answers if we can. All right. Now for the kind of big moment here, and this is this is a requirement. This is the only time that you're kind of required to use a specific strategy. If there's more than one variable in your problem, you have to use cross products. Okay, it's about the only way to do it. It's the only way that we're going to cover. Of course, there is another way. It's a lot more involved, but there is another way. And it essentially, at one point or another, turns into doing cross products, just taking a little bit longer to do it. So whenever I see 2 variables here, I see one W there and another W there, I'm going to use cross products. Negative 5 times 2 is negative 10W. And this side turns into W plus 4 times 6. I'm going to write that this way. Okay, just cueing myself to be able to distribute. I have negative 10W equals 6W plus 24. And this also brings in variables on both sides. So I need to subtract 6W. And I get negative 16W is equal to 24. Divide both sides by negative 16. And W is going to equal, they're both multiples of 8. I'm going to say it's negative 3 over 2. And there we go. So you can see where these problems with multiple variables are going to get a little bit more involved. There's going to be distributive property a lot of the time, and there's going to be variables on both sides. So let's try that same strategy on this one. R times 3, and then 5 times R plus 4. Distribute. 5R plus 20. Move your R's to the same side, which we covered last unit. So we're still working on that. I don't expect that we're perfect at that, but we should be somewhat competent. And we get R is equal to negative 10. On the last one here, I do have 2 x's involved, so I do need to use cross products. There's actually going to be distributing on both sides as well. So we'll distribute on both sides, kind of at the same time. 3x plus 6 equals 8x minus 8. And here, just like before, we have options of how to solve this. I'm going to move my variables to the right and move my numbers to the left. 3x's cancel. That gives me 14. This gives me 5x. And these cancel. Divide by 5. And we're just going to leave that as 14 over 5. A little bit more involved of a problem, but things that we've seen before. Okay. Go ahead and pause the video and try these 3. Hopefully you had a chance to do that. Let's go ahead and see how you did. This one I'm actually going to just use my solving equation strategy and show you what that looks like. You might have used cross products, and that's totally okay. I'm going to multiply both sides by 27, and I'm actually not going to reduce anything. I'm just going to see what we get here. That's going to be 54 over 3. I am going to reduce that. Actually, what if we don't? Let's pretend we didn't notice that. Let's go ahead and divide by 3. Dividing by 3 is the same as multiplying by 1/3. And we get 54 over 9. That's a little bit easier to deal with. It is 6. So however you did that, you might have gotten that 54 equals 9k. That would be okay also, and that would get your job done. Okay. You'd be, like I said, whatever way you decide to do this, a lot of the times you end up getting the same numbers that you're dealing with. It's just in what order that can make things better or worse. Depends on how you look at it. This one we probably cross multiply. We need to. So I got -2 times 4x plus 2w equals 6 times w minus 10. And I will distribute on both sides. -8 minus 4w equals 6w minus 60. Getting a big number there. Hopefully that ends up working out. We'll add 4w to both sides. And we'll add 60 to both sides. Doesn't look like it's going to work out great, but it's not going to be the end of the world. -8 and positive 60 looks like 52. 4w's cancel. I get 10w there, and my 60's cancel. Divide by 10. They're both multiples of 2. That's going to be 26 over 5. Okay, and last but not least, same type of problem. We want to cross multiply. Kind of writing this on the wrong side, but that's okay. Can always flip things over the equal sign. I need to distribute over here. And this one will work out pretty nice when I subtract 6x. Got stuck with w's. We get x over here, 15 over there. Pen's lagging out a little bit, which is perfect because we're at the end. Otherwise, make sure you get any questions over there on the left-hand side. Make sure you ask them when we meet. Otherwise, I hope you have a great day, and we will see you in class.